Okay, to do these problems, we're going to have to use the Pythagorean identity that I told you about in class here towards the end of class. I just put a little video together here to help some of those. And I know some of you are going to probably question how to do this. So what we're looking for is to use sine squared theta plus cosine squared theta is equal to 1. We have to use that formula. Now, like we talked about in class, there's two different ways of writing sine squared theta. That is fine as well. Both those two things mean the same thing. The power of 2 is put here to eliminate any ambiguity in regards to what is getting squared. So here we're basically taking sine of theta times sine of theta. We want to write it that way so we don't think this, where that is equivalent to sine of theta times theta, which is something completely different. So that's the reason why we write it this way, to eliminate, like I said, that ambiguity. So we want to write the cosine in terms of the sine. So write the first trigonometric function in terms of the second. So cosine in terms of sine. So that means we're solving for cosine. And when we're done, everything that is on the other side of the equation should only have sine in it. So we have to isolate that. Okay, so isolating cosine, we'll go cosine squared theta is equal to 1 minus sine squared theta. Now this is cosine squared, so we only want cosine. So obviously we take the square root here, and then come over here and take square root there. So it gives me cosine of theta is equal then to, remember, taking square root of something, it's plus or minus 1 minus sine squared theta. Okay. Now the only thing is that we got to pay attention, because you look at the answer here, that's not the same thing we have here. It says theta in quadrant 4. Okay, so if I'm thinking about theta in quadrant 4, okay, so it's something like that. All right. In quadrant 4, remember, all students take calculus. Cosine is positive in quadrant 4, and that's what we're trying to solve for, is cosine's positive. So that's why we get rid of the negative there, and we just leave it as positive. Okay. Doing another one here. Now it says secant in terms of sine. So again, same concept. Secant, sine, cosine, cosecant, they're all related to one another through this formula. Cosine squared theta plus sine squared theta is equal to 1. Okay. So secant is the reciprocal of cosine. So let's go ahead and go back to the last one we just did. We solved for cosine. We got that cosine of theta was equal to, plus or minus again, and we'll talk about why we're doing plus or minus again, 1 minus sine squared theta. Okay? So again, with plus or minus, because I haven't paid attention to what quadrant. Now we're going to go theta's in the first quadrant. Well, theta's in the first quadrant, so maybe it's an angle like that. The cosine, the x value in the first quadrant is positive, so the cosine in the first quadrant is going to be positive. All right, if it told me that I was looking in the second quadrant here, some of you might have that, cosine in the second quadrant, that theta, then you would get rid of the plus and you would leave a minus. Okay, so as we're going through this, we want cosine, we got cosine. But cosine is not secant. We want secant. Well, we know that cosine, if I take its reciprocal, so 1 over cosine of theta, should equal secant. So if I take 1 over cosine of this side, so I basically find the reciprocal of this side, find the reciprocal of this side. Well, this is all over 1, so the reciprocal of that side would be 1 divided by square root of 1 minus sine squared theta. And now I rewrite 1 over cosine. It's easier or better to write it as secant theta. Working down to this last one, it's the same concept, but now we have to use a different trig ratio, or trig identity. In this one, it's still called a Pythagorean identity. It's actually a variation of sine squared plus cosine squared, and it's tangent squared theta plus 1 is equal to secant squared theta. So we're going to solve for secant in regards to tangent. Okay, so if I look at this, so secant's already isolated, just take square root of both sides. So I have secant of theta is equal to plus or minus en tangent squared theta plus 1. All right, now we're in the second quadrant. Okay, so second quadrant would be a theta like that, maybe. Okay, and secant, remember, secant is the reciprocal of cosine, right? So whatever the sine of cosine is in the second quadrant is the same as the sine of secant in the second quadrant. So if I have negative 1/2, its reciprocal is negative 2/1, so the reciprocals have the same sign. So like I said, cosine over here is negative, so secant is going to be negative. That's why we get rid of this plus, and we leave a negative result. These trig identities are going to be a huge part of this course and then the upcoming chapters. The number one thing that you need to know, and I'll show you how you get the other ones, is that sine squared theta plus cosine squared theta is equal to 1. This trig identity is a direct result from this. And then a lot of the identities that we come up with throughout the rest of the year are direct results for this. For instance, this is an identity now. Okay, as long as I know theta is in the second quadrant, so let's say theta is between 90 and 180 degrees, I know 100% that if I want secant of theta, whatever that value is, I can actually type it into this and get the same result. Okay, identities mean this thing here and that thing there are always equal regardless of what you choose for theta, as long as it's the same on both sides, obviously. That's your variable. Hope this helps.